Security for agent runtimes is shifting from reactive filters to proactive tripwires. One example, Beelzebub MCP honeypots adds trap functions to Model Context Protocol MCP tool lists, APIs the agent should never call. Any invocation is an immediate signal of prompt injection or adversarial manipulation, letting operators block the run and capture the injection for analysis. Even if attackers know honeypots exist, they can't reliably distinguish traps from legitimate tools, echoing traditional network honeypots. It's open source and designed for low false positives by construction. Complementing traps, OpenAI released GPT-OS Safeguard, a pair of safety reasoning models, 120B and a 20B variant that fits 16 GB VRAM, geared for input-output filtering and content labeling. They consume your written policy, bring your own policy, and expose their chain of thought for transparency, with adjustable reasoning effort and an Apache 2.0 license for deployment. The models aim at safety cases rather than general chat, and are part of the Roost Model Community Initiative. Note they require the Harmony format to work correctly. The weak link often isn't the model, it's the boundary between documents and the agent. A LinkedIn post warned how a simple link click can cascade into data leakage, timely given how agents browse and follow redirects. Treat external links as untrusted inputs and strip risky affordances before ingestion. A concrete example from local setups. OneNote exported PDFs with embedded files or launch annotations failed to process in OpenWebUI, returning extracted content is not available. Even after Adobe Redact Sanitize, the loader still refused them, likely by design to avoid executing embedded objects. For local RAG, prefer flattening to plain text or PDFs with all attachments annotations removed server-side. Offensive testing meets hardening. On the offensive side, Raptor, recursive autonomous penetration testing and observation robot, combines frontier LLMs, local models, fuzzing, and binary instrumentation to aid vulnerability discovery and POC generation. The team integrates static analyzers like SemGrep and CodeQL, and even proposes CI integration, but sets appropriate expectations. It's an assistant, not a replacement for expert reverse engineers. Patch generation alongside POCs is where time savings materialize by cutting the back and forth with development. Meanwhile, 3 new Run C vulnerabilities, CVE 2025-3133, CVE 2025-52565, CVE 2025-52881, underline how small race windows become big problems. Each stems from time of check to time of use, top 2 flaws in mount logic. Validate a path, then mount it. In between, an attacker swaps the path with a symlink so Run C mounts a sensitive directory into the container. Consequences range from running arbitrary root-level scripts via core pattern handling to controlling low-level kernel behavior through interfaces like sysrqtrigger, even undermining LSM policy application via misdirected writes. Patches are out, 1.2.8, 1.3 4.0 RC3. Defense in-depth options include rootless workloads and blocking symlink creation in protected directories, potentially with BPF LSM hooks. Tools like Raptor are well positioned to stress these race-prone edges as part of automated pipelines, but as both efforts suggest, judgment remains the differentiator. LLMs can surface many potentials. Humans still adjudicate exploitability. Agentic coding without the slop. Agent frameworks are getting more dynamic and less brittle. Hephaestus lets agents discover and spawn their own tasks across analyze, implement, test phases, with RAG-powered semantic memory for sharing findings, Guardian monitors to prevent drift, and a Kanban interface to manage blocking relationships. In a demo, a validation agent found a caching pattern that could speed routes by 40% and spawned a fresh investigation. Exactly the kind of opportunistic branching rigid pipelines miss. It's early and rough, but the pattern, self-structuring work informed by evidence, is the point. At the editor edge, RuCode's new release adds Moonshot Kimi K2 thinking support and Minimax prompt caching to cut latencies and costs, plus UI improvements, home layout, unified diffs, line numbers, and safety valves like auto retry on empty assistant responses. Small ergonomics like these often determine whether AI coding tools feel like superpowers or friction. Discipline needs tooling too. Claude Bumper Lanes enforces incremental code review gates by computing a weighted diff score. Edits count more than new files. Touching many files adds scatter penalty, deletions don't count, and blocking further writes when the threshold is exceeded. 400 points, roughly 400 lossy of additions. It snapshots the working tree at session start and diffs against that baseline, forcing periodic review before more changes. This kind of guardrail for throughput is a practical counter to vibe coding sprawl. The cultural debate is catching up. A widely shared LinkedIn post summarized a developer's complaint, being told to just use cursor and ship in a day, with understanding becoming optional. Replies skewed toward weary empathy and systemic critique. Optimism hinged on review and discipline. The pattern is familiar. When velocity is the only metric, comprehension is the first casualty. Mandating tools without guardrails trades short-term throughput for cognitive debt and fragile systems. That skepticism extends to big claims. One open-source IDE pitch touted a custom 800 gigabyte model trained on 1.2 gigabytes of hardcore coding, prompting calls for demos and evidence. Healthy pressure testing is how the community maintains standards. RAG that plans and reasons. Retrieval augmented generation still struggles with multi-hop questions where the right evidence sequence depends on prior steps. Opera tackles this by cleanly separating planning from execution, then tightly coupling reasoning and retrieval at each hop. A plan agent decomposes the question into sub-goals with explicit placeholders, expected info type, and dependency links. An analysis answer agent judges whether current context is sufficient and extracts answers. When it isn't, a rewrite agent reformulates the query based on the plan, the identified gaps, and the full trajectory memory, states, rationales, retrieved docs. The result is a reasoning-driven loop that adapts plans mid-execution. To train such a system, the paper introduces MapG, multi-agents progressive group relative policy optimization. Each agent gets role-specific reward functions. Optimization proceeds sequentially to solve credit assignment and prevent downstream agents from training on unrealistic distributions. KL regularized, group relative advantages stabilize learning without collapsing policies, and unlike preference-only methods, retain scalar feedback. Across complex multi-hop benchmarks, the authors report superior performance versus planner-first RAG variants and single-agent React-style loops, attributing gains to explicit, inspectable plans and step-conditioned reformulation. It's part of a larger trend to make retrieval subservient to reasoning rather than the other way around. A separate RxEve preprint was also linked in today's feed without additional context. Vision language goes agentic and embodied. Qwen3VL is pushing vision language models into GUI operating visual agent territory. The 2B instruct checkpoint brings native 256K context extendable to 1M, improved OCR across 32 languages, long horizon video with timestamp alignment, stronger spatial perception, 2D and some 3D grounding, and upgraded recognition across categories. Under the hood, interleaved MROP allocates positional frequencies over time, width, and height. DeepStack fuses multi-level VIT features for sharper alignment. It ships in dense and MOE flavors, with thinking additions for reasoning-heavy tasks, and runs via standard Transformers code. On the robotics side, Dexbotic consolidates visual language action, VLA research into a single codebase that reproduces multiple policies, e.g., Pi0 CogAt, off provided pre-trained models. It supports both simulation, simpler env, Calvin Libero, and real-world ARMS, UR5 Franca Aloha, offers Dockerized environments, unified data formats, and options from 8x A100 H100 down to a single RTX 4090 for deployment. Inference can be direct or via a model server, with example prompts like put both mocha pots on the stove in Libero. Production pipelines also live downstream of DCC tools. Blender 5.1 is in beta until February 4, 2026, a reminder that the 3D assets and animation stacks feeding embodied AI keep evolving on their own cadence. Indexes that keep up. Under heavy agent traffic, retrieval infra needs to be fast and consistent. Antares is a hackable, embeddable vector database experimenting with HNSW graphs in a write-fast, update-later approach. Store a vector immediately, acknowledge success, then queue HNSW updates asynchronously. That speeds writes but risks degraded search if the update queue backs up. The roadmap shifts to structure of arrays layouts. contiguous memory for vectors and adjacency, so searches become sequential reads amenable to SIMD, and rebuilds become batchable. To address consistency, Antares proposes immutable snapshots. Reads hit a fully consistent index, while writes accumulate in a buffer, triggering periodic rebuilds and an atomic swap when ready. Planned features include filtered search and payload indexing over HTTP, gRPC, and hybrid multimodal search. For RAG pipelines that interleave plan-conditioned reformulation with retrieval, as in Opera, these details latency, update loss, snapshot semantics directly affect performance and determinism. Building models, runtimes, and power. There's appetite for from-scratch clarity. A new Manning book, Build DeepSeek from Scratch, aims to mirror DeepSeek R1's architecture across training and inference, releasing chapters monthly, 4 available now, with code in a public repo. The preview's scrambled text is a publisher obfuscation mechanism, not a glitch, and readers should bring at least a working knowledge of attention. For a free alternative, the small training playbook on Hugging Face covers foundational LLM training practices. On deployment efficiency, a clever visualization used image reconstruction to compare 4-bit quantization schemes. The MXFP4 reconstruction compressed to half the PNG size of Q4-No, consistent with visible banding and flattened gradients, while IQ4KSS preserved more detail. The takeaway: MXFP4 may underperform unless models are trained or fine-tuned with format awareness. For rigor, the author points to perplexity and KLD comparisons against BF16 baselines. Systems literacy still pays. A recent write-up on writing your own beam walks through building a minimal Erlang VM, a reminder that understanding runtimes demystifies the stack above. And on the hardware side, a DIY Powerwall project reportedly outperformed cloud and commercial options, an offbeat but relevant note as more teams weigh local energy and compute resilience for on-prem AI.